Chapter 18, question 179. Now, in this question, we need to consider structural isomerism and also stereoisomerism. Now, when they mention this in the question, what they're trying to say is, if a compound, okay, can show cis-trans isomerism, okay, or optical isomerism, the cis isomer, trans isomer, okay, each of them should be considered as one isomer. So if a compound exhibits cis-trans isomerism, okay, it is considered two isomers. Alright, now let's look at the question. Each of the following carbonyl compounds is reacted with sodium borohydride. This is reduction, right? Reduction. After that, the product each reaction is heated with aluminium oxide at 600 degrees Celsius. This is dehydration. Okay, then one or more products will be formed. So which carbonyl compound will produce the most isomers? We have no choice. Let's look at the answers one by one. Now, as A, butanol. Okay, enjoy it here. Now, butanol 4-carbon aldehyde. Right, this is butanol. The rest are okay, alkyl groups, carbon bonded with all the hydrogen. Now, first reacted with sodium borohydride. Okay, reduction. So this aldehyde functional group will be reduced to a primary alcohol. Now erase this. It became a primary alcohol. After that, let's do dehydration. So I'm going to remove this, okay, this OH. Then with 1 H from the adjacent carbon. So I will get alkene. H, H. Then this one also another H. Now let's look at this product. The 2 carbon sharing the double bond. Okay, this carbon is bonded to 2 hydrogen. This carbon is bonded to two different groups of atoms. Now, because this carbon is bonded to the 2 groups of same type of atom, so no cis-trans isomerism. A will only give you one product. Now let's look at B. Now we have butanol. Erase this. I'll keep the 2 carbon because butanol is still 4 carbon. Oh, forgot. Let's erase this and write B. Okay, butanol means we have double bond, okay, on the second carbon for the carbonyl group. Right, this is butanol. Okay, now butanol first undergo reduction will give us a secondary alcohol. Yeah, so here I'll get a secondary alcohol. So now, the dehydration of this secondary alcohol will give us more than one product this time. Why? Okay, very obviously, it has two adjacent carbons. Both also have hydrogen. So again, we have to first again look at the product where hydrogen is being eliminated from the carbon on the left. Then after that, we look at the carbon on the right. Okay. So I want to remove one hydrogen from this carbon first. So I'll get a double bond between these two carbon atoms. Okay, this is being removed. So this carbon is now bonded to one H and one CH3. This carbon, I remove one H. So it's now bonded to one H and one CH3 also. Now the two carbon, okay, in the C double bond C, they are both bonded to the different groups of atoms. So there is cis trans isomerism. Consider two products here. Two, yeah? I may circle. So two. Now right hand side. Now remove the hydrogen from the right hand side carbon. This time this, probably use a different color. So this time I will get double bond between these two carbon instead. After removing one hydrogen and the OH group, now this C is only bonded to two hydrogen. This carbon is bonded to a H and an ethyl group. Okay, because this carbon is bonded to the same type of atoms, no cis trans is considered another one product. So in total, 2 plus 1, butanol will give us 3 different products. Alright, now let's look at C. Okay, let's change the color a little bit. Okay. C is pentan-3-on. Right, a lot of changes to this now. I'm going to erase all this. Okay. We need 5 carbon this time because pentan-3-on. 1, 2, 3, 4, 5. Okay. Okay, the third carbon has a carbonyl group, pentan-3-on, right? Okay, the rest, they are alkyl groups. Okay, 2 hydrogen. Okay, 2 hydrogen, then 3 hydrogen. Right. Now first do reduction. Again, it will turn this pentan-3-on into a secondary alcohol. Let's erase this. Right. So now we do dehydration. So we can remove the hydrogen from the left hand side adjacent carbon or the right hand side adjacent carbon. But can you see that this pentan-3-on, this molecule has a plan of symmetry? Left hand side, right hand side, they are the same, yeah? Okay, now this is important because you're going to see that removing hydrogen from the left hand side adjacent carbon or the right hand side adjacent carbon will give you the same product. So okay, we just draw and see. So I remove hydrogen from this carbon, okay, and remove the OH from this carbon. I'll get a double bond between these two carbon atoms. After removing the H, now it is only bonded to CH3 and H. This carbon, after removing the OH, it is bonded to H and the ethyl group. Okay, now let's remove the hydrogen from the right hand side adjacent carbon. So remove this OH, remove this H. Double bond between these two carbon. After removing this H, now this carbon is bonded to one hydrogen and one methyl group. This carbon, after removing the OH, is bonded to one hydrogen and one ethyl group. Now, can you see that they are the same thing? Right? You see the two carbon sharing the double bond. Okay, one is bonded to CH3 and H, the other one H and ethyl. Okay, CH3 and H, okay, H and then ethyl group. So they are the same thing. Right? So I don't consider these two are two different products. They are just one same type of product. So I'm going to erase this, yeah, because we are not getting different products here. Alright, now let's look at whether this product has cis-trans isomers or not. Each carbon bonded to two different groups of atoms, yes, will have cis isomer, trans isomer. So consider two products. So C will give us two products. So far, butanone is the winner. It has the most isomer as products now. We now check the last compound, propanone. Right, there are a lot of things to erase because propanone has only 3 carbon. Alright, now 3 carbon. I'm going to erase this also. I'm drawing propanone now, yeah, because we are looking at the last compound, the propanone 3 carbon ketone. Okay, again, will be reduced to a secondary alcohol. Okay, now it's another symmetrical ketone, secondary alcohol, where removing hydrogen from the left hand side carbon or right hand side carbon will give you the same type of alkene. So I'm not going to draw it 2 times, okay, because I've shown you that in C, when you have a symmetrical alcohol like this, okay, dehydration will give you same type of alkene. Okay, now let's remove the hydrogen from the neighbor carbon. Okay, remove the H from this carbon. So this carbon is now left with only 2 hydrogen. Remove this. Okay, so 2 hydrogen. Now this C, remove this OH. Now bonded to 1 H and a CH3. Okay, there's no need to remove the hydrogen from the right hand side carbon anymore. You will get the same alkene. Now look at this alkene. Any cis-trans isomerism shown by this alkene? Okay, no, because this carbon is not bonded to 2 different groups. It's bonded to 2 hydrogen. Okay, no cis-trans, so only one product. Alright, so which one gives you the most isomers? The answer is B, 3 isomers.